Welcome everybody, and thank you for the invitation to this mini-symposium. My name is Annika Reinke, and I'd like to tell you about our ongoing research on benchmarking competitions. I want to start with a short anecdote. So in the city of Vietnam, there was a rat plague, and the government wanted to get rid of the rats. So they announced a monetary reward for everybody who brought rat tails to the government. So people started to bring the tails to the government. They earned the money, but the problem was the rats survived. People just cut off the rat tails and let the rats live so they could proceed to reproduce, so that the people would earn more money from that. The outcome of the whole thing was that there were more rats than before. So I like this anecdote because it translates somehow to machine learning and AI. If we want to validate an algorithm, we usually define a goal and a metric to see how our algorithm performed to solve this goal. And if the metric isn't really the right way and isn't proper for this goal, as in our case with the rat tails, then the validation is more or less useless. So we should really think about what we want and what we want to show and how we show it. If we validate algorithms on a fair platform, nowadays we usually perform challenges or benchmarking competitions where different algorithms compete against each other on the same problem. Based on the same data set, they will evaluate it with the same metrics. A ranking is often computed so that we find out who is the winner for the specific goal. And the winner is quite important because there are often high prize monies for a challenge. The method is highly cited, new state of the art, so it is very important. And I think this is a step that should be really well thought through. So these challenges are very valuable. But we had a closer look at them and asked ourselves the question, is the winner really the best? So we had a closer look at the discrepancy of the very high impact of challenges. Challenges are just extremely important and very valuable for our field, but there was nearly no quality control for them. So together with a very large consortium of about, I think it was more than 30 different institutions worldwide, we had a closer look into challenges, and I want to share some results with you. Over the past years, the number of challenges has been rising. And we now see a trend that challenges are standard for prestigious conferences and platforms like Kaggle. There are also many task categories in our challenges, with segmentation being the largest proportion of challenges, which is somehow reasonable because in research segmentation is still a big field. I'd like to focus on a few things that are important for challenges, and one of them are the metrics. I already talked about this rat plague problem with rat tails being somehow the metric of this problem, which wasn't the right choice. So also in machine learning applications, we should really think about the metrics. In segmentation, most of us use the dice similarity coefficient, which is also performed very often in challenges. As you see on the right, this is an overlap metric between the reference annotation and the algorithm's prediction. But we should think about before using dice, not only because everybody is using the dice, it's the perfect metric for every segmentation problem. In this example from Professor Tal Abel, the goal is to segment very, very tiny objects. So as you see, the reference annotation is only a few pixels. Here we have a prediction where only one pixel is missing basically, and the dice already drops to 0.88. If we remove one more pixel, so only 2 pixels missing, we have a dice value of 0.75. So we basically dropped a quarter of the dice value by only losing 2 pixels. So in this case, dice isn't the right choice. So before we define the metric for a challenge or for our benchmarking algorithm validation in general, we should really think about what we want to show. Rankings are also very important for competitions where we want to find a winner. And we investigated instability of rankings, ranking robustness, because we think this should be very robust against some perturbations. And here we computed a ranking correlation coefficient called Kendall's tau between two rankings, and it somehow measures if the ranking stable or not. In this box plot, you see real challenges where we compare two different rank computation methods. And we picked one example challenge with 13 algorithms, and you see on the right the ranks of algorithm 1 to 13. The two rank computation methods that we applied here were the aggregation of single metric values for each algorithm. Usually this is done by the mean, and we thought, let's have a look what happens if we exchange mean by median. And this is what happens. The ranking changes somehow dramatically because algorithm 1 and 5 exchange the ranks, and this is something that really shouldn't happen. And we had more examples like this. In one example, the last ranked algorithm was suddenly the winner by exchanging the metric variant a little bit. So we found that the challenge rankings are very sensitive to a range of different challenge design parameters. And for the ranking, the same holds true as for the metrics. You should really think about it, and the ranking also should reflect your challenge goal. As we can interpret challenges as validation studies, reporting is one very essential step. As this paper states, the one practice that can be universally commended is the transparent and complete reporting of all facets of a study. So we want to ensure that our challenge or our validation study is interpretable and reproducible. Together with our large consortium, we compiled a list of important challenge design parameters. Some of them are very important for validation in general. Some of them are specific to challenges. For example, there's things like how many training and test cases do we have, which metrics did we use, if we have some missing values in the submissions, how do we handle them in the rankings? Were there annotation instructions, how did they look? All these things really matter to a challenge. And we analyzed more than 500 competitions and had a look at how many parameters were reported. And basically reporting is not so good as it should be. So only about 2/3 of the parameters were reported as a median. And one example would be that 85% of challenges, so a very high amount, didn't give any instructions on whether the training data that was provided by the challenge organizers may be complemented by external data or not, which is a very important point if you want to ensure a fair comparison. We thought about some solutions for this reporting problem. And the first step that the MICAI conference, the Conference on Medical Image Computing and Computer-Assisted Interventions, founded a working group for challenges. And with this working group, we introduced the Biomedical Image Analysis Challenges Initiative, short BIAS. And our goal is to bring BIAS challenges to the next level of quality. The first step of our working group then was, of our initiative then was to design a checklist and a guideline for designing and reporting studies like challenges, and registered this guideline with the Equator Network. Equator is a platform that is very common in the context of clinical trials. And we think that we can learn a lot from clinical trials because they are somehow the equivalent to validation studies and challenges in our domain. So this guideline was used in our structured challenge submission system, which we implemented for the MICAI conference. So if organizers wanted to submit a challenge to MICAI, they had to fill out all these parameters. So we forced them to think in a structured way and really help them that they don't forget any important aspects of their challenge, especially if they were new to the field. And this also enabled us to have a peer review process similar to the one for papers. And this system was kind of was also used for other conferences, which I think is a very good sign. The guideline looked somehow like this. We had some parameter names, some sections, the explanations and definitions of the different parameters, something like state the total number of cases, why did you choose this number of cases, how did you choose the proportion between training and test data, etc. And then there was a column in which you could insert where this information was given, for example, in the challenge paper. This made it very easy for the authors, for the challenge reviewers to check if the paper reviewers, if everything was reported, and also for a reader of the challenge paper, because it's very easy to find some specific information. But the problem is we can't control what challenge organizers do after the challenge was accepted. In the box plot below, you see the percentage of reported parameters per challenge. Before we introduced the submission system, where I already said median about 64%. And in 2018, where we introduced the submission system, where we forced them to have a very high reported percentage. But we had to look at the challenge websites a few months later, and yeah, the number of reported parameters really dropped down. So we thought we would need to integrate one more step into the whole workflow. So the challenge was submitted. We had a review process where we had direct quality control. Some challenges were accepted. And before directly executing the challenge, we inserted one step where we uploaded the challenge document so that it was visible to everybody. And challenge organizers were forced to tell us if they had some changes to this design. Everybody could see the whole design on a different platform. So we listed all accepted challenges, gave them a DOI so that we also had some versioning control. And I think that this year was the first year where we started this project process, and it really worked out quite well. So the challenges that had changes just told us, and then we uploaded a new version and everything was fine. Everybody could have a look at that. Okay, so far we talked about the challenge design, reporting of results, reporting of the challenge design. And now let's have a look at the result analysis, which is of course very important in challenges. Here we again had a look at our 500 competitions, and we found that in the papers, 27% were only based on ranking lists without any kind of result visualization. And let me show you why this is a problem. So here you have two competitions on the left and the right. The metric values are for the individual images are shown with blue dots and are compiled in a box plot for every algorithm. Although they look quite different, they share the exact same ranking. And now imagine that you only report this ranking table, you get very little information about the details of the algorithm differences. To investigate the ranking variability, we always use bootstrapping. So we perform some sampling with replacement on the test data to create more bootstrap data sets and perform the rankings on each of these bootstrap data sets to investigate the ranking variability in case of randomness. And here we introduced so-called block plots, which show the frequency of the different ranks across the bootstrap data sets for each algorithm. And a large radius of a block means that this rank occurred very often during bootstrapping. So we see on the left that the ranking is very, it's very clear. Algorithm 1 is always on rank 1 across all 1,000 bootstrap data sets. On the right, we see that the ranking is very unclear. It's not very robust against some perturbations. We also had more and other different aspects in our toolkit, so it's open source. You can just insert a table of ranking of metric values, and you get a full PDF report with different visualization techniques, ranking analysis, and explanation of all of these things. So if you want, really try it out, have a look at our paper. Our research is still ongoing, so there are many open issues, and I just wanted to point to some of them in the end. So in the mathematicians community, there's the so-called polymath project where mathematicians work together on difficult mathematical problems. And this is something, so this idea of collaborative challenges, I saw that in a few challenges in the past, but only very few. But I think this could improve efficiency on solving problems in our domain by working together and not only have this competition thinking. Another thing that might be important is the question, what can we actually learn from the challenge? Is my goal solved? Which kind of algorithm really won the method? So there was a paper that had a look at a challenges leaderboard from 2019, a kidney tumor segmentation challenge. And they had a look at the architectures of the different algorithms from rank 1 to rank 100. And they found that most of them use a 3D unit-like basic architecture, but they were spread across the whole leaderboard. And there is the question, why was this specific algorithm better than the others? Why is some 3D unit on rank 1? Why is some of them on rank 100? What was the difference? Was it something like data augmentation strategies? Were there some cool methods in the network like attention modules or residual connections? What was it? What can we learn from that also for algorithm design? And finally, there's this problem that many algorithms are very good, but most of them are not translated into clinical practice because they lack generalization problems, lack generalization capabilities. And there are many propositions. What is the reason for that problem? One might be that, so you have your available data, you split it into training and test, but both training and test data come from the same distribution, right? They or a similar distribution, and it's very hard to generalize them. So here I want to point to a recent paper that dealt with causality and medical imaging and also talks about this problem about generalizability. And I really recommend reading it. It's very interesting and formalizes all the different things in medical imaging. So let me sum up a few things that I told you during the talk. We talked about the challenge design, and here I pointed to some facts about the ranking and the metrics that should really be thought through, and I recommend to have a look at our papers. The challenge execution is one point that I haven't talked about due to timing reasons, but this is also covered in our papers. For the analysis of challenge results, you should really use visualization techniques, not only report the ranking lists. And this can also be applied to benchmarking in general and to validating your own algorithms. It's not specific to challenges. And finally, reporting is a very important step. Here we introduce the guideline, and you should also have this in mind while writing your own algorithm paper. So I would then like to thank you for your attention, and I'm very happy to answer questions. Thank you.